All right, so based on my last video where we talked about um, setting up a DevOps tooling website solution with respect to the the architecture um, shown on your screen, where we have a DB server, a NFS server, which is the network file system server, then a set of web servers, then we have the clients. And this is what we call a three theater application setup. And one of the key thing is a typical application setup usually have or application server usually have three main concerns, right? We have the DB for storage of information and the likes, and secondly, we'll talk about application server management, logs, and the likes, and finally, we talk about request processing, which is the CPU or the processes the application is running. And typically, right, you want to set this up on a machine and stuff like that. But there's something we call separation of concern, where you want those three core concern or the key core aspect of an application to be separated into several servers, dedicated servers that will be responsible for that particular specific aspect of the application, and you want to connect them in such a way that even though they are running on separate servers, they can communicate with each other and share information. And this is the main focus of having this kind of setup where we have a dedicated servers for the database, a dedicated server for the application files and the like, then a dedicated servers or group of servers that are responsible for processing requests. Their major focus here is to process requests from the client and serve a client with the respective file by communicating with the NFT server. At the same time, they communicate with the database to be able to serve the client with the respective information. You want to log in, communicate with the database to know is this person authorized to log in. If it's yes, if the response is yes, okay. Based on the login, what did the client, what are they trying to see? Oh, they want to see the dashboard. Oh, NFC, give me the dashboard file. Then they get that, and they process the file, render it, and show it to the client. So, which is kind of similar to what you find in a typical restaurant where you have the kitchen, the cashiers, and the servers. And each one of them, are focused on their respective job, but they, each person's job is kind of interrelated, and that's what we are trying to deplete in this program. Why this kind of makes a lot of sense and introduce a lot of flexibility into the architecture, and with the introduction of the logical volume manager where you can it make it also easy to make use of dynamic storage system, right? But the downside of this setup is that the client have to be aware beforehand the number of servers that you are running, the number of application servers. Though the client has no direct access to this, but the client has to know how many application servers you have, and how many web servers you have, and how they are going to access the web server by sharing the either the URLs or the IP. For now, it's more like the IP that we have. And for me, that is not really That's not really the best. Imagine I have 100 servers running for the web, whatever. That means I have to tell my client, oh, I have 100 servers, web servers that you can use to apply, access my application. Like Google has millions of servers running for google.com, and they don't need to tell us, oh, we have so number of servers. All I needed to do is just go to google.com. Whatever the servers that are responding, I don't care. I don't want to know about it. So, and this will bring us to our today's video tutorial talking about how do we ensure that we can run as many servers as we want based on our unique need, but our clients will only be exposed to one, right? They will only be exposed to one, and that one will be responsible for allocating the right web servers to the client based on different configuration that been set. And that server is what we call the load balancer server. Yes, in AWS have a native load balancer service, load balancer as a service. But today we are focusing on setting up our own local load balancer without relying on what AWS have as their service. And basically, what we are doing is we are still going to maintain our previous setup. What we are just doing is just introduce this load balancer between the clients, which is what you have here. These are more like clients, different server. So instead of me, opening up 3 of these, what I need to do is introduce one server that will be responsible for allocating any of these based on need without the client knowing how many servers, web servers I'm running. I might choose to add more in the future based on need. I might choose to terminate, maybe 1 or 2 based on need. But the client doesn't need to know that, right? All they need to know is that anytime they come to my site, they can always access my site. And so the whole essence of having a load balancer is basically to increase application availability, enhance scalability for handling traffic, improve security against DDoS, and improve overall application performance and the like. The way we have set it up, we kind of increase overall performance availability. If any of the servers is down, the load balancer is smart enough to know that it won't need to direct traffic to the unavailable servers, and they will distribute the traffic among the available server until the server comes back online. If you don't, if you missed my last video, you can easily have access to this before jumping on today's implementation. And I've also included some links to good, if you want to probably learn more on load balancers and how to implement and the likes, you can see a lot of those information down here. You can go through them, learn a lot. What we are trying to achieve is still basically the same thing we achieve, but instead of going through it through different 3 different servers, we are basically going to use one single server. So I have my basic setup from the last tutorial, nothing fancy, still the same basic setup. I have my security groups, one for the NFS, one for the DB, and one for the web server. Then the volumes that we set up is still basically the same. Nothing really fancy, nothing really different. We still maintain the basic architecture. So if you check my previous video, it will help you to quickly set up the basic architecture of what we did in the last video. So in today's video, which I believe should be quicker, we are only focusing on setting up the load balancer server, which I'm going to do by clicking on launch instance. And we are going to call this load balancer server. For this, we are using Ubuntu for this particular setup. We are maintaining the T2 micro. I'm using my key pair. Then for the network, I'm going to create a new one, right? But before then, I have to ensure that this is within the same availability zone for the rest of the instances I've launched. Then we are going to call this load balancer, right? I'm going to say this is the security group for the load balancer server, right? The SSH is fine. No, so this will be my IP. Then I'll add one more, which is for the HTTP, and that will be anywhere. And that's just the basic setup. You still maintain the 8 gig, which is fine, because the major focus of the load balancer is not really processing anything, it's just redirecting traffic to the right server that will process the request. So, and it's not storing anything. So, the basic configuration or the basic storage is fine for this particular usage. So, let me log in into my load balancer. I will connect to my load balancer for now, right? So let me launch my instance and my terminal, cd DevOps. Then I can paste this to log in into this, which is fine. Yes. So let me increase this so that you can see exactly. So we are currently in, right? I've taken the pain to do a complete documentation of the entire approach, which you can see on the screen, right? So I also left some information, basic information about the various layers where load balancer is applicable. Now we have launched the servers, I've set up the various IPs and the likes, and now so the first step is to copy this. We are updating and upgrading, which is fine. So just paste this. Well, although it's two commands, but both of them will be run sequentially. The batch is smart enough to know that we are running two separate commands. So let's wait for that to be done. It's usually quicker compared to what we experienced with Red Hat. So I'll paste this other command to install Apache and to also install the library called library XML2 dev. Basically, it will be working in respect to this writer and some other Apache proxy in which you'll be able to manage the communication between the load balancer and the web server. So I think that should be done. So what we need to do is to start our Apache and enable it for auto rebooting, which is done. So I can clear that. And the next thing I want to do is to enable the various modules from Apache that will be responsible for the load balancer application, which just copy and paste all those commands, which is fine. So what I've done is click on this to copy all of them at the same time and paste. Then I want to restart my Apache to ensure that everything is working fine. Well, to confirm that your Apache is working, you might choose to check on the browser, but it's particularly not necessary at this point because we are not really concerned about the web server that is running on this application on this uh, server per se, what we want to do is more of traffic redirection to the appropriate server, a web server. So we have done this, and you can check the status of our Apache, which shows that it's currently running and everything is looking fine. Everything is looking fine. So the next thing is to configure the our Apache to be able to handle this. So I'm going to open up the base configuration. So let me see. I should have a nano already installed on this. So perfect. So what I need to do is come down to this side, basic application. Then what we need to do basically is we just need this portion for now. Um, Ensure that you replace this IP address with your web server's IP address, which are the so I have three web addresses. So if you have to, in case of you are running, so just update this with the private IP. These are the private IPs of your web servers. Just replace those with that, and that should work fine. That should work fine. So for my case, so all I need to do is copy this section. I just show you the entire virtual host configuration for you to know where to kind of paste your configuration file. So let me see, it's not here. So let's return this. So paste here, which is fine. So let me just ensure that it's well aligned using my tab key. Okay, I think, let me see. Yes, that should be fine. Right, so can move this in. Let me just align it properly before this thing is showing me some wiggling lines. So let me see if this will be fine. I think you can ignore the red whatever for now. So I move this in. I think this should be fine. I move this in. Just want to have it properly formatted to ensure that everything is looking good. Right, so I think this should be fine. Well, not to worry, we can test it out to ensure that what we did was okay. So I save this for now, and I can really check, I can easily check if my configuration is fine by trying to restart my Apache. If I run into error, that means something is wrong. But since there's no error, which means everything is fine, and now why this is configured properly, we need to now tell, um, so if you go back to the security group, right, in our, we're supposed to have one security group here, all right, so let me call this load. It's always a good practice to label out, to name things so that you know exactly what you are dealing with. Now we have this inbound rule for the web server that is open to the internet. But what we are going to do is we will not open it back to the internet. We will direct it back to the load balancer. And for us to do that, you will remember that when we were kind of setting up our NFS, we kind of look at the subnets, the subnet block. So we are going to connect our web server to the load balancer using the subnet block. And what we are saying that any traffic coming from the subnets, the web server should respond to it. And given the fact that the load balancer and the web server are within the same subnet, it is easier for them to accept traffic from the load balancer. So what we'll do is the load balancer is already connected to the internet based on the security group we kind of set up earlier. Let me see. So the load balancer is kind of, let's quickly check this while I'm trying to copy. So what I need is this. I just copy this, which is the subnet block CRO, call it CIDR, or we call it the subnet block. So if you look at the setup we have for the load balancer, we have the port 80 connected to the internet, which means the client can access the load balancer from the internet. So what we needed to do is reconnect the web server to the load balancer so that when the load balancer is redirecting traffic from the client, it will be able to connect to the web server. In the configuration, let me quickly just explain the configuration. This is telling the load balancer that, oh, I have 3 web servers you should be redirecting to, and you should redirect the traffic equally or the request equally. But then we are setting that which method is it using. We are saying redirect using traffic. There are several methods like redirect through request, I think heartbeat and the likes. You can find more information by reading the documentation. But based on what we have set up, so we are telling, okay, redirect based on traffic. Then we set up what we call the sticky session, and the main impact of this is a PHP application. So we are making use of the PHP session ID to track which server was connected to and to track the session. And when we say the session, what we are saying that if a client connects to a server, right, and probably logging into the application, we ensure that we keep that particular client on that server throughout their session, throughout the period they have within the application, in such a way that, because if the load balancer redirect the client to another server in between the interaction with the application, the clients will be logged out automatically and they will need to log in. And the funny thing is, without this, you will probably be stuck in the login process loop for as long as God knows, because the load balancer will not be able to to know, or because what we are running is more of based on our architecture, are running what we call a stateless system where the web server does not keep the states. But with the load balancer and the sticky session, we are able to keep a client connected so as long as they are interacting with the application and the session is still valid. So this the main reason why we have this kind of setup to preserve the user. So these are just basic configuration, and based on what we have set up, when you come to this, I think this has been properly set up, and I think we are fine. So instead of me, going through now, if I try to use this now, it's going to fail because we have actually prevent the client from accessing any of our web server directly, and we have kind of put a layer between our web server and the client by introducing the load balancer. Now, if I where's my load balancer? Yes. So if I click on this and copy the IP and go to this, so this is going to fail basically. So there's no need wasting time. Let me just, because we are using port 80. Now you can see that through the load balancer, I can actually connect to my application. So we are going to do something quite interesting, right? To see how all this is working. I'm going to open up each of the application server so that we can see how the load balancer is actually interacting with them. See this DevOps. Right, so let me increase this. This is server 3. I'll use this for server 2, and I'll use this for server 1. So let's quickly connect. So I'll just do let me be sure that okay, let's try to connect to server 1 first. So this is server 1. Hopefully we can connect, but I'm not 100% sure. So let me check. Let me quickly check. Let me quickly check my security group for the SSH to be sure that I have the right permission based on my IP. Given that my IP is dynamic, it changes quite often. Let me see, as suspected, that's changed. So let me cancel this. Oh, perfect. I've recognized it. So this is fine. Then let's go back to server 2, web server 2. Let's copy this, click quickly, then let's paste this there. So why that is okay, that was fast. Let's do server 3. Server 3. Let me connect. Sorry, this is what I'm supposed to copy. So let's connect. So let me come to server 1. So why this is working, we can quickly check the log of what is happening by doing this. Now you can see that there was a request on my there was a request around 9:21. This is 10:21. So let me just refresh. Let me just refresh this. Hopefully it's going to pick. So we are on the login page. So if you go back to your, yes, to the load balancer, you can see there's a get request from login by 10:24. Although it's saying 9 because this is GMT, I'm in GMT plus 1. So let's just ignore this part. We just focus on the 24:21, which is just now, right? So there was a request, right? There's a get request. Now, let me quickly copy the same thing. Let me copy this command. Let's access each. So I'm going to do, instead of Apache 2, for this it will be HTTP. It will be HTTPD, I think. Access. I think it's access log. I'm not sure. Let me see if I have the command here. All right, so if you come to my documentation, let's see. Okay, so for this, I think it is right. So I'm gonna come here. I'm gonna paste this to see the access log. So this is the access log. So last request on this was around 9:20. Just an HTTP get request, which is the base URL. So let's check this. So same thing here for server 2. So we want to know which of the server responded to the load balancer. So let's see. Okay, yes, you can see there's a request here which matches the request showing on the load balancer at the same timing, which means that based on this page that we are on, the load balancer routed that request to web server 3. As you can see, if you go back, right, you can still see, okay, let me see. Now it's routing this to let me see this. No, this is not it. Yeah, this is it. This is it. It's routing it now back to web server 1. You can see the request was 2702, which is the same 2702. So the request comes through the load balancer and it was routed to web server 1. Let's try to refresh the page one more time. And let's confirm. Now, this server 1, there's no requesting coming here. From the load balancer, we can see that there's another request on 2746, but we don't find that. So let's check this. You can see now he has routed that to this, right? In fact, there's another. Okay, he has routed that to this, which is this. Sorry, I think there was an error. I mistakenly copied down some code. But you can see here is the request that was served. So you can see that the more we refresh, as we refresh our browser, the load balancer redirects those traffic to different. Now I've refreshed again, which is 2834. Let me see. You can see 2834 is coming to the web server 3. So let's try to log in. So my user password, right? So let me show you something. We try to log in, but we are getting pushback. Based on that request, is not on. So let me go back here. You can see uh, there was a request as 29:05 to log in and display the tooling dashboard, but immediately there was also a get request because I think the session has not yet kicked in, right? But that is being handled by. So let's check. Okay, let's check these two. Okay, so look at this. This request was handled. The login request was handled. The dashboard request was handled by web server 2, as you can see, right? This tooling, but you can see that the next request. So the first request was a get request to get this, right? Why the web server 2 is trying to get this, a post request. So a post request was first sent in. So when you try to log in, there will be a post request to the login page to submit your login credential, which was handled by server 1, right? So while that was processed, a get request was sent after the post request was successful. A get request was sent to get the admin tooling page, and instead of server 1 to handle that, because server 1 was the one that handled the login, which means is in charge of the session ID. Load balancer kind of sent the get request to web server 1, and because the web server 2, and because of the web server 2 does not have the session ID, so he's not aware that the user is currently logged in, and because of that, a new request was sent to web server 3 to get the login page. So, and that's the tricky part of a load balancer, because if you do not track that a user is logged in, within the space of time, within this time period, 3 separate requests were sent: a post request to log in the user, a get request to get the dashboard, and because a different server was handling that, the get request for the dashboard, he could not get that. So a new request was generated from the client side to get the login page, and that was handled by a different server. So that's one of the basic, one of the downsides. So, and that's where the sticky configuration comes in. This part comes in. We just need to, I think it takes a bit of time for that to kick in, but let's try once again. Try that once again, right? So I'm having a bit of challenge that. So let's refresh my Apache. So let me come back here. Sorry. Let's restart the Apache. So let's hope that this time it will recognize. Let me do index.php. Alright, so let's see. Take a bit of time to kick in, but once it kick in, everything should be fine. Yes. So now, so let's go and observe what's happening. From here, you can see the tooling. So after the login, the first login failed. Second login, after the login, the tooling kicks in and was able to fetch the page. So let's check which of them. So let's see. Okay, there was a post request. there was a get request, right? And there was a post request, and so he was able to maintain all these requests on this single server, server one, right? It was okay, server one, right? I'm getting a lot of okay. So server one was the one that was able to, get stick. So let's try to refresh this. If everything is working fine, the user should still keep signed in. So still getting that. So let's try again. And the reason why this happened is because if you come back to this, when we refresh the page, let me come back here. When we refresh the page, it kicks in the login to ask for login, and if you look at this is the tooling. This is web server 3. What happened is web server 1 was the one that logged in initially. But I'm 100% sure, oh yes, it has moved to web server 2, right? And that's where we have the post request from here, right? And we are able to log in from here, identify customer present. So let me try to refresh and see if it will still keep us logged in. Yes, now it's working fine now. If I keep refreshing my pages, let's go and see if it still maintain the same server. So you can see there's a lot of image requests for the same page. Let's see which of the server has been handling that. Definitely is not this. Definitely is not this. So server 3 is the one that is handling, I think is the one handling our request. The last request was 9:35. Let's see, 9:35, 56. Let me see if that's the same thing. No, it's not. Let's see, 56. No. Yes, so web server 1 is the one handling it. So let's refresh again and see if it will still maintain the web server 1. The last request is, our last request is 56:48. Let's see, 56, this 50, 55, 56:48. Interestingly, he was able to keep us logged in, despite that the requests were routed to another of the server, which is fantastic. So the interesting thing is that it's able to recognize the session, and based on the session ID, it is able to keep the user perpetually logged in, irrespective of which of the servers is responding to the traffic. The last request here is, let me see, is 27:45, and the 27:45 is not this server. 27:45 is server 2. So that's the benefit of the load balancer. It can manage the traffic and ensure that the traffic is well distributed across the web server, to ensure that a single web server is not being overwhelmed by traffic or requests. So that's just that. And if you want to go a step further, instead of you using bare the IP address directly, you can kind of add those to your web hosts. Let me just quickly show you how that works. So let me cancel this. So you can just come here, then down here you can just add your IP addresses, which is what I have here, and I'll just name them. So I can just say web servers IPs. Um, this kind of put a bit of, so if I have 100 IPs, I have to include all of them here, right? And it kind of, it doesn't make it more, kind of put a kind of a restriction on how flexible the system can be. But anyway, but it makes our configuration a bit neater. So I can go back to my configuration here, and instead of the just the IP addresses here, I can just change them to, I can just do this web 1, web 2, web 3. I think that's just the configuration, web 1, web 2, web 3. I use small letter though, so even though this is capital letter. So I think it doesn't matter provided that what you are saving it as is the same as what you declared. So I can just start Apache, as you can see. Right. The only difference is just it makes it a bit neater, but no more. You can see even though I've changed them to web 1, web 2, I am still equally still logged in. So that's just the basics of configuring your load balancer on Apache. And at the end of the day, if you follow the guide, you should be able to have this. I believe in the subsequent videos, we'll be able to implement some um, SSL and TSL security communication, probably add a domain name to the entire configuration and see where it is. Thank you for taking time to watch my video, and I hope you can click on the like button and also subscribe to my channel so that you can get notification when new videos comes in. Thank you.